This is the last lesson on vectors. It will finish up 3.14 and 3.13 and 3.14. Yeah, so vector product, not to be confused with scalar product. It's the reason I wanted these to be separate. And then area of a parallelogram. So this is about thinking in 3 dimensions again. So if you've got you've got 2 vectors u and v, and w is perpendicular, and then here t is perpendicular. So you could have 2 different vectors, w and t, that are both perpendicular to u and v, but you don't know if it's going down or coming out. Or if you think of the 3rd dimension is coming at you, like at the screen, or going away from the screen. So how do you know which way it's going? I'm not sure if you'll need to be able to know which way it's going, but you'll have to be able to find that vector for sure. And so that is called the cross product. So not the dot product. These are different things. So that's why we're using different notation, and this is where it gets really confusing. U x v, or u times v, is going to give you a perpendicular vector at the intersection. So either this t or this w, and we'll worry about which one it is a little bit later. The vector product, remember, this is telling us, this is helping us get this formula that we came up before with the angle in between 2 vectors. So this is different. This result, u dot v, is just a number. It should be one number, like 22 is what we got before. But the cross product is actually a vector. Okay, so this is how you know which way it's going. Cognitive goes through this. It's called the right-hand rule. So if you put your hand just like this, your right hand, just like this picture, and you hold your right hand so your fingers point in the direction of vector u. So as you can see, just hold your right hand exactly like the screen. Then curl your fingers just like it is. Your thumb is now pointing in the direction of u times v. So it's going to be coming up. But if, in order to get it the other way, if actually I should post a different video where I can show you my hand curling. So I'm going to do that. It's easy in this case to figure out when it's going up. But when it's going down, it's a little bit trickier. So I'll post a different video for that. So then here is, this is given to you to find this cross product. It looks pretty horrible, but there's kind of an easier way to actually do this. This is like, this part down here is trying to give you a formula for how it works. And there's really not much intuition behind this. Like, it's just matrices and how they work, how they're defined to work. So notice this minus sign is kind of a weird thing. The first one's positive, then minus, then positive, and then these are always subtracting. So basically we're just taking, it's kind of like the dot product, but not exactly, because the result is a vector, I, j, k, and not just a number. So I'll go through an example where I don't even think you'll need to know this if you go through enough examples. So given a vector in 3 dimensions, find the vector product. So we have to know, okay, vector product versus dot product. This one means it's going to be harder. Dot product is easy. It's this just where you're doing -2 times 2 plus 1 times -2 plus 3 times 1. This is the easy dot product. It just equals a number. -4 minus 2 plus 3. That's -6. It's almost too easy to, like, you do it really fast and you mess up. That's the dot product. But the vector product, this is how I would suggest doing this. Writing the ijk first, and now taking the first vector and writing it out as a unit vector, -2i plus 1j plus 3k, because that's what we have going in this row. The next one, write that again, 2i minus 2j plus k. That's this row. Okay, because now it becomes a game of determinants, and determinants are really easy to find with a 2x2 matrix. There's no way to do this vector product on your calculator if you're wondering. So that would look like this. So what's happening? I'm taking the I component, so I, but I'm ignoring this whole column. This whole column's like getting wiped out, and I'm finding the determinant of the 1, -2, 3, 1 matrix. Okay, so the determinant is let's say A, B, C, D. The determinant is A, D minus B, C. So that's why I'm doing 1 times 1, which is this 1, and then minus -6, because 3 times -2 is -6, but we minus that. And then the next calculation we do, we always have a minus for the j component, is now we ignore this j column, and we do the matrix -2, 3, 2, 1. So that's with, if I remove the j column, I have a 2x2 matrix. And then that's why I'm doing -2 times 1, and then minus 2 times 3, which is -6. Then we cross out the k component, and we're left with this 2x2 matrix right here. And so we get -2 times -2 is 4, and then minus 2. And so all together we have 1 minus -6 is 7i minus -8j, so that makes it plus 8j, and then plus 2k. That would be the vector product. And again, you should be getting a vector. You could write it as a column vector like this too. So let me just let me go to my calculator here, and I'm gonna just show you. This is a common. Let me enter these vectors in as a matrix. The way I've done it right here. So edit. And this would be this matrix, this -2, 1, 3, 2, -2, 1. Let's enter that in as a 2x3 matrix, and we get -2, 1, 3, 2, -2, 1. And now, what happens if I go back to matrix and I say math, and I want the determinant? This is, oops, I need to go back to the home screen. If I do matrix math, I say determinant of matrix A, it says error, because we can only find the determinant of a square matrix. So you would have to break these into all 3 square matrices if you want to use your calculator. There's nothing else that's going to give us, nothing that says vector product here that's going to help us. So this is the only way to do this by hand. Okay, now we're told a vector, or we want to find a vector of length 3 that's perpendicular to both v and w. Because remember, if we find u times v, we're finding a perpendicular vector. But now we just want that vector to be of length 3. So we're going to go back to a few lessons ago how we did that. So the first thing we need to do is find that vector, but this is the same exact vectors I just did. So we got 7i plus 8j plus 2k, and now we just need to make it a length 3. So what do? We find the magnitude, which is using the Pythagorean theorem, or 3-dimensional Pythagorean theorem. And then if I multiply 1 over the magnitude times my original vector, that gives us the unit vector of length 1. And then if we want this to be length 3, all we have to do is then multiply it all by 3. So then this would be a vector of length 3 that's perpendicular to both of these two vectors. Pretty hard to see, like in your head, what's going on. You just have to trust the method. But not too hard to calculate, actually. Okay, next one. Consider 3 points with coordinates a, b, c relative to a fixed point O. Find AB times CB. So AB times CB. There's a problem here because we don't know AB and CB. We just know the points. So we have to go all the way back and find AB first. So vector AB by doing the coordinates of B minus the coordinates of A. So we get -1 minus 1 is -2. 2 minus 1 is 1, and 1 minus 1 is 0. So that's the vector AB. Then we need to go find CB by doing the coordinates of B minus C. And there we go, 0. So this is CB. -1 minus -1 would be 0. 2 minus 3 is -1, and 1 minus 1 is 0. You could enter all these in as matrices again, but it's going to be so much work. And yeah, I wouldn't do it that way. So then to find the actual vector product, write down I, j, k, and turn these matrices into unit vectors, -2i plus j plus 0k. That looks like okay. And then we've got 0i minus j plus 0k, and I've written those out like this. And now practice again using determinants. So with the I column, we're just doing 0 minus 0, because if I ignore the whole I column, I have this matrix left. So the determinant would be 0 times 1 minus 0 times -1. It's just 0 times 0. So that wipes out this whole I component. The j component's also wiped out, because when I ignore that second column, I'm left with this matrix. The determinant of that matrix is 0. Like I said, you could enter these matrices into your calculator and do the determinant, but it's pretty easy by hand. But if you prefer, I mean, I can show you. You have to have a 2 by 2 matrix, and then let's just leave it like this, and I can show you really quick. You just go back to matrix math, determinant, then go back to matrix, pull up the one you have, and it will tell you, it will do that calculation for you, because I mean, that was quick enough if you're really good with the calculator. And then the last one, if we ignore the k row or k column, then we have -2, 1, 0, -1. And I think that's exactly what I just did. We're left with 2k. So 2k is the result here. Oops. Okay. Or we could write it 0, 0, 2, like that, in column vector form. Okay. Now now we can connect all this to the area of a parallelogram and triangle. We're going to get a formula for both of these. And so the formula booklet tells us to get the area of this parallelogram, all we have to do is the vector product. But then do the magnitude of that result. So this is kind of cool how this works. And then to get the triangle, all we would have to do is cut it in half. So we have a bunch of different ways to find the areas of triangles now. 1/2 magnitude of A times B. Remember, we also have 1/2 AB sine C. So all kinds of different ways. So consider a quadrilateral with these coordinates. We could show that this is a parallelogram first, and then we could find the area. So let's do it. how do we show that it's a parallelogram? Well, we find all of these. So AB be 5, 1, 1 minus 2, 0, 4. So that would be 3, 1, negative 3. And then we want to find, I'm going to be careful with this, like which ones do we actually need to find? Let's find, like if I say A, like I know it's a parallelogram. Whoops, what am I doing? A, let's say it's like this. Let's say that's what our parallelogram is. A, B, C, D. Okay, I would need to find AB and then B, and then I want to compare that to DC. So that means I need to do C minus D. So negative 1, 1, 3 minus negative 4, 0, 6. And negative 1 minus negative 4 is 3. 1 minus 0 is 1. 3 minus 6 is negative 3. Okay, and we can see these are parallel because, well, they're exactly the same. Okay, and so then their lengths would be the same because if I found the magnitude of each one, they would be the same. So I could call this vector A. This is really the same thing as vector A. This could be my vector B. And this could be also vector B. So then I want to find a BC. Let's do that over here, BC. So that's C minus B. So negative 1, 1, 3 minus 5, 1, 1. So that would be negative 1 minus 5 is negative 6. 1 minus 1 is 0. 3 minus 1 is 2. Okay, and then we want to find the last one is AD. And then we do negative 4, 0, 6 minus D. D minus A. So minus 2, 0, 4. So that's going to be negative 4 minus 2 is negative 6, 0. And that's a 6. So 6 minus 4 is 2. And we can see those are exactly the same. So they're not only parallel, but they'll have the same length. So we've shown that it's a parallelogram. Now to find the area, all we have to do is the vector product I, J, K. And now we want to use just this vector AB and D and AD. Or you could do CD times BC, either way, as long as you're doing just one times another one. So I'm going to do AB times AD. So AB is 3, 1, negative 3. Now we have to write them out as a unit vector. And then AD is negative 6, 0, 2. Okay, now when we ignore the I column, we're left with 1, negative 3, 0, 2. So we want the determinant of that. Determinant would be 2 minus 0, because 0 times negative 3 is 0. And so that's 2i. Okay, the next component is going to be j. So we're going to ignore the middle one and get 3, negative 6, 2. Determinant of that would be 3 times 2 is 6 minus negative 3 times negative 6 is positive 18. So 6 minus 18 is negative 12j. And then the k component, we're going to ignore that one and get 3, 1, negative 6, 0. And do 3 times 0 is 0 minus negative 6. So that's positive 6k. Okay, so there's my vector 2i minus 12j plus 6k. And now to get the area, we need to find the magnitude. So 2 squared plus 12, plus 12 squared plus 6 squared. Take the square root of all of that. So I'm going to do that on my calculator. Let's see, 2 squared plus 12 squared plus 6 squared. Take the square root of that. And I get 13.56, but I'd round it to 13.6. 13.6 square units. So quite a bit of work on a problem like that. Lots of really small, tedious calculations to mess up So be careful as you're going through it, and practice. Thanks for watching.